Scott left the airport and traveled towards the train station. 3 hours later, Castell left, traveling at 50 miles an hour in an effort to catch up to Scott. After traveling for 2 hours, Castell finally caught up. What was Scott's average speed? These are distance, rate, and time problems. So the main idea is the idea that distance equals rate times time. So what I have to do is I have to draw two pictures about two different people doing something that has to do with distance, rate, and time, and try to gather as much information as I can. So let's focus on Scott. Scott left one place, he traveled, and then eventually he stopped when this other guy caught up to him. What do we know about Scott? Well, he left the airport and traveled towards the train station. Who cares? 3 hours later, Castell left, traveling 50 miles per hour in an effort to catch up to Scott. After traveling for 2 hours, Castell finally caught up. So what do I know? Do I know his distance? No, I don't. Do I know his rate? No, I don't. Do I know Scott's time? Yes. Because he left, and after 3 hours, this other guy left, and after 2 hours, he caught up. So what I know about Scott is his time was t. But again, that's all I know. So let's take a look at the other guy, and let's take a look at his situation. Okay, he left 3 hours later. Okay, so they leave from the same exact spot. He's traveling at 50 miles an hour, so we have a rate for him, and his rate is 50 miles per hour. In an effort to catch up to Scott, after traveling for 2 hours, he caught up. So this is what we know. His time was 2 hours, his rate was 50, and his distance that he traveled was the same. So these guys have the same exact distance. So this is what we know. We have Scott, we have Castell. I hope I'm pronouncing that right. Their distances are the same. Their distances are the same, which means their rate times time is the same. So we have Scott's rate, we have Scott's time. So I'll put RT knowing that I'm going to erase this, and R and T knowing that I'm going to erase that. So we have Scott's rate, which I don't know. We have Scott's time, which I do know. That's 5. So I'm going to replace Scott's T with 5. We have Castell's rate, that's 50. I'm going to replace Castell's rate with 50. And we have his time, which is 2, so I'm going to replace that with 2. So now in an effort to clean this up, I have R times 5, which is 5R, equals 50 times 20, which is 100. Divide both sides by 5, divide both sides by 5, cross you out, and R equals 20. Now, what does that mean? Well, the R that I have is the rate for Scott. Okay, so we're dealing with hours, we're dealing with miles, we're dealing with miles per hour. Scott's rate, or his average speed, was 20 miles per hour. So that's how we do these problems. You have D equals RT. You try to figure out the things that are equal to each other and try to draw pictures of what you have. There might be times where the rates are different. There might be times where the times are the same. It doesn't really matter. You're just trying to figure out what's equal and base some type of equation off of that. And this is what we came up with.